class, and welcome to lesson 8.8, Sine Law. Hopefully you guys last class did your quiz, and hopefully you've got some feedback on that. So remember, that quiz, folks, was a consolidation of trigonometry as well as Pythagorean theorem using right triangles. Today we're going to start taking a look at those triangles that do not have a 90-degree angle in them, and they're called oblique triangles. But before we get into the sine law, we're going to do warm-ups. Now notice on these warm-ups, folks, you've got one equation equaling, one fraction equaling another, or one rational expression equaling another, and we're going to use cross-multiply to solve. This is a key component that we're going to be setting up for when we deal with the sine law. Okay, so we'll be comparing side lengths with their opposite angles, and we're going to be equaling them to another side length. So similar to what we did in similar triangles in terms of proportional ratios and cross multiplying, but a little different in how we set it up. So let's just try our warm-ups from what we know. Cross multiply, you're going to get 9x equals 30. And x equals 30 divided by 9. And you leave it as a fraction, that's fine. Okay. Later on, when we get to doing units, we'll put that information in. Okay. This one, B, is a little tricky because the expression is a binomial up here. So when you cross multiply 4 times that, it's going to be 4 times x plus 3 equals your other cross, which is 2 times 12, which is 24. Don't forget distributive law, ladies and gentlemen. So it's going to be 4x plus 12 equals 24. Now we're going to get the variable term by itself, so it'll be 4x there. Bring the 12 over, becomes negative. I apologize, it should be 24. Subtract 12. Okay, so that's going to be 4x equals 12. Divide both sides by 4, and x equals 3. Okay? All right, taking a look at, now we're going to set it in with trigonometry. So you're going to notice when we do this, ladies and gentlemen, that we have to cross multiply and then isolate the variable. So I'm going to start with my first cross that has the variable term in it. So it's going to be x sine 31 degrees equals my other cross, which I'll just change colors till you get the hang of this, which is 12 sine 47 degrees. Okay. Now what we want to do here, folks, is we want to get x by itself. So currently it's times by sine 31. You got to do the opposite, which is divide by sine 31. Whatever you do to one side, you do to the same to the other. So that cancels that out. So you've got x equals 12 sine 47 degrees divided by sine 31 degrees. Plug her in your calculator, ladies and gentlemen, and you're going to get x equals 17. Okay, and that'll be units of centimeters, meters, kilometers, whatever the units are given in the triangle. Okay, I want to show you a quick shortcut here. Okay, and I'm going to fix that spelling because that looks pretty bad. Sorry, I can spell better or neater than that. So, short cut. Okay. All right, so if I take the original question, which is x over sine of 47 degrees equals 12 over sine 31 degrees. Okay, what I'm going to do differently, folks, is I'm going to put x equals. I'm going to start with the opposite cross, which does not have x involved, which is 12 sine 47 degrees. Okay, and what we would normally multiply x by first, we'd have to also divide it like we did up here. So we're just going to automatically divide it by sine 31 degrees. Just saves you a line. Okay, so then you'd plug that in your calculator, x equals 17. Again, make sure your calculator's in degree mode, and you should be knowing by now how to plug that in. If you still need help, let me know. All right, take a look here, folks. We're going to do question D. Now, question D is a little different in that we're finding a missing angle. Notice in C, folks, it was a lowercase x. That tells you we're looking for a side. Okay, in D, it's a capital X, which means we're now going to find an angle. So we've got to do things a little differently when we plug in our calculator. But the setup is going to be similar. So do the same cross. So it's going to be 5 sine of X. Make sure that's a capital X, okay? Equals 3 sine of 22 degrees. Okay, now to get sine X by itself, you divide both sides by 5. So we're going to have sine X equals 3 sine 22 divided by 5. And again, you could have used that shortcut again. That's fine. Okay, but remember what we have to do differently now to get the angle, ladies and gentlemen. You have to use those inverse buttons in your calculator. So angle X equals the sine inverse of this whole relationship in brackets, or this ratio in brackets. So 3 sine 22 degrees divided by 5. All right, plug that in your calculator, folks, and you should get angle X equals, I think, 13 degrees. All right, so there's our warm-ups, ladies and gentlemen. Let's take a look at the sine law. Okay, recall, ladies and gentlemen, when we've got a right triangle, we can make calculations using two things. Okay, one is Pythagorean theorem. So that's c squared equals a squared plus b squared. And we use that when we have 2 out of 3 sides. And we need third side. Okay, let me just fix up the word third. Okay, so that's when we use Pythagorean theorem. Okay. Or we learned most recently, number 2, how to use SOHCAHTOA. And hopefully you've got that memorized by now. And that's dealing with angles and sides. You have to have at least one angle in there, or find an angle. Okay? And remember, folks, for a right triangle, you got 90 degrees, right? Okay, have to have that. Okay, what happens when we have an oblique triangle? Just remember, guys, by definition, oblique means that there is no 90-degree angle. So we're going to draw it differently. We're just going to draw it like this. And we're not drawing it to scale, but just make sure you draw it so you don't see a 90-degree. Well, you're going to use one of two formulas. You're going to use A, which is called the sine law, not the ratio, because the ratio is the SOHCAHTOA part, the SO part. So if I say ratio, it's dealing with a right triangle, but if I say sine law, it's dealing with an oblique triangle. And sine law is going to be used when you have what's called a match. I'll explain that a little bit in more detail, but basically you're given an angle with its opposite side with the values given. Okay? And then if you don't have a match, then you're going to use the more harder one, which is called cosine law. So cosine law is like your last resort. Okay? And you're going to use that when you get side, angle, side, or side, side, side. Okay? And if it's side, 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 you've got to find an angle. Okay? All right. So ladies and gentlemen, I would like you to write this down. And this is our box that tells us about sine law. Okay, so as I mentioned in the warm-ups, ladies and gentlemen, we are going to be setting up proportional ratios. Now you'll notice here, by definition, ladies and gentlemen, we have one fraction equaling another fraction equaling another. That just corresponds because there's 3 sides. In all cases, we're only going to use 2 fractions. So pretend we just, for example, cover up B. You could use A and C, okay, depending on where your detailed information is given. Okay, so although it's 3, because that's the definition, because there's 3 sides in a triangle, we're only going to be using 2. All right, so what it says here for sine law, folks, is you need to have a match, and that's a given angle and its corresponding side. We'll practice that down below, okay, what a match looks like. And we will set up 2 equivalent fractions, cross multiply like we did in warm-ups, and isolate the unknown to solve it. All right, so let's take a look at what a match looks like, ladies and gentlemen. If you need to pause the video at any time to write that stuff down because I'm going too fast, by all means do that. All right, so we want to take a look at what a match is. So notice here we're given this, in example A, we're given this angle 42, Okay, that's our given angle. And notice the opposite side's given. I'm going to put a little kind of like oval mark on it. That's your match because you're given an opposite side to the given angle. Okay? Likewise, in example B, we've got two angles given here, a 37 and a 48, but it's not opposite the given side length. Is there a way we can find this given angle, ladies and gentlemen? Yes, there is, because if you know two angles in a triangle, you can find the third. So to find that angle, it's going to be 180 degrees. Subtract the two given angles, which are 48 and 37. Okay, once you've subtracted them, ladies and gentlemen, you're going to have 95 degrees. And again, if you're wondering what that short form is, angle sum triangle theorem. So now we can put 95 degrees in. And now we do have a match. Although it wasn't given, we were able to calculate it. So there's a match. Okay. Example C here, ladies and gentlemen. We've got one angle given and no side length given, but then we're given another side length. The key here, folks, is in this triangle. Hopefully you notice those tick marks. Those indicate that it's an isosceles triangle. So what does that tell us, folks? That the two base angles must be the same. Okay, these have to be the same. So we can solve for them, ladies and gentlemen. And what do we know about a triangle? That all the angles add up to 180 degrees. So x plus x is 2x plus 32 equals 180 degrees. Okay, let's get the x term by itself. So 2x equals, you take 180 and subtract 32. It's going to be 148. Okay, divide both by 2. X equals 74 degrees. Now that we know that this is 74 degrees, ladies and gentlemen, now we have a match. And you could use the other, you could use this as a match as well. Okay, I always just circle one. Okay, on an isosceles triangle, if you have one match, guess what? You're going to have the second match if they are the base angles that you found. Okay? All right, let's take a look at actually doing some of this. All right? Okay, we can do it. So, example 2, calculate B for each below. First of all, I want you to identify where side B is. So B is opposite, side B is opposite angle B. Okay, and then you look for a given match. First of all, strategy. I look at my triangle. Do I have a 90-degree angle? Because that's easier if you got a 90 degree. No, we don't. So we can't use Pythagorean theorem. We can't use SOHCAHTOA. So now we have to use sine law. We look for a match. Do we have a match? Yes, indeed we do. Side A and angle A are the match. Okay, so what I'm going to do is, watch carefully here, I'm going to take the side that I'm trying to find, which is B, divide it by the sine of its angle. So that's, I apologize, I got to sneeze. Excuse me. The sine of the angle B, which is 42 degrees, okay, equals, where is the information in the match that we have? The side A, which is 12, over sine of whatever the angle A is, which is 38 degrees. So for those who need trouble getting started because you don't see where that comes from, what I'm doing is I'm taking B over the sine of B equals A over the sine of A. So if you go back to that formula that we had on the previous page right here, we're using the B side and the A side, so we're ignoring the C side. Okay? All right. Now, ladies and gentlemen, it's the same thing. We need to get that B term by itself. Okay? So to get the B term by itself, I will do, for this one, folks, I will do the cross multiply and isolate. And the next one, I'll show you the shortcut. So we're going to go B sine 38 degrees. Sorry. No mistake there. 38 degrees equals the opposite cross, which is 12 sine 42 degrees. To get B by itself, divide by sine 38, whatever you do to one side. Do the same to the other, ladies and gentlemen. So we're left with B equals 12 sine 42 degrees divided by sine of 38 degrees. Okay, plug it in your calculator. B equals, apologize, have to sneeze again. Excuse me, 13.0, and our units are centimeters. All right, let's try example B. So example B, ladies and gentlemen, we look at the side length, but we don't have the angle that matches the given side length, but we can find it. Okay, so what we need to do is realize that if we're given two angles in a triangle, we can find the third. Just give me 1 sec, sorry. After sneezing, my nose is running. Thank you. Sorry about that. I know that's probably too much information, Miss Art, but anyway, we're back. So we're going to find angle D. So angle D equals 180 degrees, subtract 37 degrees, subtract 44 degrees. Okay, so angle D equals 99 degrees. I'm going to put that in my diagram because I found it. And again, if you want to know the short form, that's ASTT. Okay, that short form itself replaces showing all that work. So if you want to just write this down, you can, or show the work and give the answer. Now that we have, ladies and gentlemen, the angle and its opposite side, we now have a match. Okay? And again, thinking of strategy, looking at this triangle, folks, we don't have a 90-degree angle, so we can't use SOHCAHTOA, can't use Pythagorean theorem, so we now have a match. So we're going to set this up. We need to find side B. So side B is opposite angle B. So we go B, which is the side length, over the angle of sine B, so that's going to be sine of 44, equals the match. So it's going to be 13 over sine of 99 degrees. Okay? Now I'm going to show you the short form. So I'm going to know it's going to be B. I'm going to do the opposite cross first. So I'm going to go B equals the opposite cross, which is 13 sine 44. And I'm going to divide it by what I would normally multiply it by, which is the sine of 99 degrees. Okay, think about it. If you've got that bar across here, those are the multipliers, and then think of that kind of like as a divides by line. And you're going to divide by the term we haven't, that we would normally multiply, we're going to end up dividing. Okay? Plug it in your calculators, folk, and you're going to get 9.1 feet. What do we have to remember about that, ladies and gentlemen, is that we don't have decimals in imperial units. So I take my calculator and I go 0.1 times 12. And that equals 1 inch. Okay, so B equals 9 feet 1 inch. Okay, again, how I did that, folks, I know I've got 9 whole feet. I take the 0.1 that's left over, times it by 12 inches in a foot, and that gives you the 1 inch. Okay? Awesome. Okay, so folks, that's finding side lengths. Okay, let's see if I have another one here. Now we're going to find angles. Okay, so do things a little bit different here. Okay, so let's find the angle. All right, so to find the angle, we also have to be given the side that's opposite to it. Okay, so for example, in 3A, it says calculate angle C. So angle C is what we're trying to find. Good news is we have the side length that's attached to it. Okay, looking at our triangle, folks, do we have a 90-degree angle? No, because it's not given. Can't use SOHCAHTOA, can't use Pythagorean theorem. Do we have a match? Yes. A is our match because we've got angle A and side A that have measurements that are given. Okay, and what are we trying to find? We're trying to find C. Okay, so I'm going to do I'm going to put up the initial form that we're going to look for. So C over the sine of C, so that would be initially what we're stepping into, finding A over the sine of A. Okay, so let's plug in our information. So we've got C is, side length C is 15 over sine C, that's what we're trying to find, okay, equals side A, which is 11, divided by sine of A, which is 29 degrees. Cross multiply here, ladies and gentlemen. Okay, now, if we're trying to find side C, okay, I'm going to use that shortcut. So if sine C is what I'm trying to find, I do the opposite cross, which is 15 sine 29 degrees. And I'm going to divide by what I haven't included yet, which is the 11. What would normally be multiplied becomes your divider. Okay, I apologize, folks. I need to have a capital C here instead of a lowercase c. So put capital C. Okay. And ladies and gentlemen, to find angle C, you got to use the sine inverse of this whole fraction in your calculator. Okay, plug her in. Angle C equals 41 degrees. All right. Great. Let's try example B. Okay. So again, we're still finding angle C, ladies and gentlemen. Okay, and we maybe don't need to put the intro statement in. I want to set it up a little differently. Okay, so if I take a look at my previous example here, folks, I have C over sine C and A over sine A. I can flip these fractions if I wanted to. So in the next example, I'm going to put the angle on the top corner. So if I'm finding side C, finding the angle C, I'm going to put sine C up top. You may like this method better. I'll show you why in a second. Okay, so sine C over side C, so that's a little lowercase, equals, where's my match? Sine of D over side D. Okay, so as long as you flip one fraction, you have to flip the other. They are also equivalent. Okay, because left side equals right side equals left side. So if you flip one left side and you flip the right side, you're both going to be fine because that's by definition property of an equation. All right, so taking a look, folks, hopefully you take a look at strategy-wise, look at triangle. Do you have a 90-degree angle? Nope, so can't use SOHCAHTOA, can't use Pythagorean theorem. If that's annoying you right now, I want you to remember that for your unit test or your exam. Okay, so think of the strategy as you go, because 90 degrees are easier than obliques. Okay, so we don't have a 90 degrees, so we can't use Pythagorean theorem, can't use SOHCAHTOA. Do we have a match? Yes, we do. Okay. All right, so let's fill in the information that we know. Sine C is what we're trying to find, divided by 19, because that's the side value for C, over sine 41 degrees, divided by 23. I like this setting up the angle first, because when I do the cross, it's a little easier. So I go sine C equals 19 sine 41 degrees. Divided by 23. If you set it up this way, then you're always going to have your unknown up at the top corner. Okay? As opposed to, in the other example, we had it as a denominator. Might be a little harder to see. Okay? Now, folks, again, it's an angle, so angle C equals the sine inverse of 19 sine 41 divided by 23. Okay? All right. Cool. Let's take a look. Oh, C is tricky. Let's see what we can do. Tricky. All right. Well, first of all, let's look at our triangle. Do we have a 90 degree? No, so it can't be Pythagorean theorem. It can't be SOHCAHTOA. We still are asked to find angle C. Looking at angle C, do we have the side length here? No, we don't. Okay. So here's the problem. There is no side C given. Okay, so we can't set up that proportional ratio like we want to. Does anybody have any other strategies to how we can find side C? Well, maybe we can't use side C. We have to do something different. I want you to remember, folks, that in a triangle, if you know two angles, you can find the third. So our strategy here is, therefore, we need to find angle E, and once we find angle E, we can use angle sum triangle theorem or subtract all the given angles from 180. All right, so we're going to find angle E. Okay, so I'm going to put that on top. So sine of E divided by the opposite side, okay, is 12 equals our match. I forgot to put that in, folks. There's our match. Okay, so that equals sine of 44 degrees divided by 9. Cross multiply and isolate. So sine E equals the opposite cross, 12 sine 44 divided by 9. Now I know I'm doing this in the video and I'm going pretty quick. Please pause the video and make sure you can plug this in your calculator. Okay, so angle E equals the sine inverse of 12 sine 44 degrees divided by 9. Angle E equals 68 degrees. Now, please, ladies and gentlemen, so many people will do that and say, aha, I'm done. But the problem is you now have to, don't forget your question asked, ask for angle C. So angle C equals 180 degrees. Subtract 44, which is given. Subtract 68, which we just found. So angle C equals 68 degrees. So here's a strategy. I want you to make sure you study this one, because this one's popular for a unit test and for final exam because it's tricky. It's your higher level thinking. Okay, so again, we weren't able to find side length C, so we didn't use that strategy. We had to pick a different strategy, which was our geometry strategy of if you find two angles in a triangle, you can find the third. All right, last example for us today, folks, is a solve question. Let's just review quickly what solve means. Solve means to find all missing side lengths and angles. Okay, and as we mentioned before, you look in the given information and you look for a 90-degree angle. And when I look, I see an angle of 38 and I see an angle of 42. I don't see an angle of 90 degrees, so I draw an oblique triangle. Okay, and just for understake, I'm going to label it A, B, and C. Okay, and now I'm going to put in my information. It says angle A is 38 degrees. So I put that down. It says angle B is 42 degrees. Okay, and it says that side A is 12 centimeters. So we already know there's no 90 degrees, so we can't use Pythagorean theorem, we can't use SOHCAHTOA, but we know we've got a match here. Okay, so that's where we're going to start off with. If we have this match, ladies and gentlemen, okay, what side length can we find based on the angle that's given? We could find side B, okay, or you could realize, it doesn't matter what strategy you do, or you could realize, hey folks, we've got two angles in a triangle, let's find the third one and get that done with first. So we're going to go angle C equals 180 degrees. As long as you get all your information on the page, it doesn't matter what strategy you do first. Okay, so I'm going to find the third angle, then I know my angles are out of the way. All right, so angle C equals 180 degrees, subtract 38 degrees, subtract 42 degrees, because of ASTT, okay? Plug in your calculator, angle C equals 100 degrees, okay? So we've got that one solved. Now let's find side B. Okay, so B over sine of the corresponding angle, which is 42 degrees, equals the match, which is 12 over sine of 38 degrees. Sorry. Okay, get B by itself. So B equals the opposite cross. See if you can do this without, or see if you can do it with the shortcut, I should say. Divide by what's left over, sine 38. Plug in your calculator, ladies and gentlemen, and you're going to get B equals approximately 13.0 centimeters. Okay? Now, don't forget, folks, we still have to find another side. We haven't found side C yet. So now we'll find side C. So C over the sine of that angle that we calculated off to the side, which was 100 degrees, equals the match that's given. Please don't use the new match that you just found in case you made an error there. Then you could get, you'll have this one wrong. So always use the given information. Okay, so it's going to be side, like the match of A instead of B. Okay, so we're going to go 12 over sine of the match given, which is 38. C equals 12 sine 100. Hopefully you got the hang of that now. Divided by sine of 38. C equals 19.2 centimeters. Awesome. So here is our first look today at oblique triangles. Sine law has a match, okay? Next day we'll be dealing what happens when we don't have a match, and that's going to be the cosine law. So here's your homework, folks. Page 447, numbers 1 to 4 and 9. Have a fabulous day, guys. And again, come see me if you need any help. Bye-bye.